Welcome, everyone, to Math Fact Fluency, specifically with multiplication and division. Before we start our talk today, I'd like to show you a snippet from a math class.
I think it's already starting. Okay, here's your homework. First let me tell you the directions. What's 4 take away 5?
1, 2, 3, 4, 5, 6.
Take away. What's 6 take away 1?
1.
No, you take away 1 out of 6. How much does it equal? What's 10 minus 1?
I don't know.
1, 2, 3, 4, 5, 6. 6, 7, 8, 9,
10.
Nope. Take away 1. How much is it?
1, 2, 3, 4, 5, 6, 7.
Nope. 1, 2, 3, 4, 5, 6, 7, 8. And 8 and 1 more. And add 1 more. How many does it equal?
1, 2, 3, 4, 5, 6, 7, 8. 1.
It makes 9. See how you take away? You take away 1 and it equals
1.
Do you get it now?
Yes.
Have you ever felt this way in math class or had students look at you in that manner? I know I have. I realized early on in my teaching career that just because I told my students, if I didn't ground that instruction with clear, precise direction and strategies, I would feel like this teacher at the end of the day. In this video, we are going to consider 3 questions. What does fluency mean? What approaches to building fluency with facts help our students become confident and competent mathematical thinkers? And what does meaningful practice look like? We know that we all want our students to be able to quickly recall or have what is known as automaticity of their math facts, whether it is their basic addition and subtraction facts or their basic multiplication and division facts. First, though, we have to understand what fluency is and what it is not. Fluency means noticing relationships and using strategies. We want our students to be able to recall with ease and automaticity of their math facts, but there truly is an art in helping our students to become fluent with their math facts. Fluency is the skill in carrying out procedures with flexibility, with accuracy, and with efficiency. Thus, far from just being a measure of speed, fluency with facts involves flexibility and accuracy by using appropriate strategies to find the answer efficiently. Defined, accuracy is the ability to produce mathematically precise answers. Efficiency is the ability to produce answers relatively quickly and easily. And flexibility is the ability to think about a problem in more than one way and to adapt or adjust thinking if necessary. It is also important that students are able to select and apply a strategy that is appropriate for solving the given problem efficiently, also known as appropriate strategy use. However, this strategy may be different for different people. And we, as teachers, must be willing to be open to students choosing strategies that work for them. According to the National Council of Teachers of Mathematics, fluency is also the ability to transfer procedures to different problems and contexts, to build or modify procedures from other procedures, and to recognize when one strategy or procedure is more appropriate to apply than another. To develop fluency, students need experience in integrating concepts and strategies and building on familiar strategies as they create their own informal strategies and procedures. Students need opportunities to justify both those informal strategies and commonly used procedures mathematically. They also need to support and justify their choices of appropriate procedures and to strengthen their understanding and skill through strategic practice. Procedural fluency builds on a foundation of conceptual understanding, strategic reasoning, and problem solving. Second, another important note to share is that fluency is knowing from memory and not the term of memorization. With repeated experiences working with a number, students can come to just know that 2 times 6 is 12 without ever having had to memorize it. At this point, we say students have mastered their multiplication facts as they have become so fluent at applying their strategies that they do so automatically without any hesitation. So how is fluency developed? Students develop fluency as they progress through 3 developmental phases. The first phase is known as foundational facts. This is where students are modeling and or counting to find an answer. After they've acquired their foundational facts, they go into our second phase known as derived-fact strategies. This is when they are deriving their answers by using reasoning strategies based on their already known foundational facts. And finally, in phase 3, we will know our students are fluent because they have been able to master their basic math facts by being able to produce efficiently the answer to the problem. Additional approaches to learning math facts, such as flashcards, drill, and time testing, attempted to move students from phase 1 directly to phase 3 without even considering phase 2. This approach is ineffective. Many students do not retain what they memorized in the long term, moving to the next grade level, still not knowing their facts. Even if students remember facts, they are unlikely to be as fluent as we have defined, as they will not have learned to flexibly apply strategies to find the answer to a math fact. Research tells us that students must deliberately progress through these phases with explicit development of reasoning strategies, which helps students master the facts and gives them a way to regenerate a fact if they have forgotten it. Students make more rapid gains in fact mastery when emphasis is placed on strategic thinking. So, how do we help children progress through the 3 phases with respect to math facts? That's a great question. Careful sequencing and explicit attention to strategy development is necessary. So let's take a moment to look how we can begin to assist our students with math fact fluency by honing in on phase 1 through explicit teaching of the foundational facts. During the first few years of school, through the meaningful practices of skip counting, working with addition doubles, and representing multiplication and division situations and arrays, children begin to learn the first set of multiplication facts, the 2s, 5s, and 10s. We recommend working with these foundational facts so that students use their skills from previous grade levels to be fluent and ready to apply them to derive other facts. The multiplication squares, such as 2 times 2, 3 times 3, 4 times 4, and also the zeros and the ones are the next set of foundational facts. Instead of teaching zeros and ones with memorization tricks, Invite students to apply their understanding of multiplication. For example, that 5 groups of 0 or 5 empty groups would give us 0 objects. So 5 times 0 is 0. Exploring situations using these facts, drawing the arrays, and looking for patterns in the multiplication table will help students learn these facts. We describe the facts above as foundational because they lay the groundwork for the derived fact strategies. By definition, derived fact strategies are based on facts that students already know. Therefore, a lack of fluency with foundational facts can lead to frustration or inefficiency when students do not quickly see a known fact in the problem they are solving, preventing them from adopting important derived fact strategies. Therefore, a lack of fluency with foundational facts can lead to frustration or inefficiency when students do not quickly see a known fact in the problem they are solving, preventing them from adopting important derived fact strategies. The foundational facts, when learned and understood, can be used for learning all other multiplication facts, such as Phase 2. Carefully chosen context and sequencing can allow particular strategies to emerge. Students can use the 2s, 5s, and 10s facts to solve nearby facts such as the 3s, 4s, 6s, and 9s. The key is to help students think of how they can work from the first fact to derive the second, related fact, as opposed to starting over and drawing an entirely new picture. In this example, where the students are presented with 3 ladybugs on a leaf and each ladybug has 6 legs, students are asked to determine how many legs there are altogether. Students may think repeated addition and know that 6 and 6 and 6 is 18. But if you are able to show students that they know 3 times 5 is 15, and one more set of 3 is 18, you'll be able to show them they can use their foundational facts to help them derive an answer. We want students to be flexible in their thinking and use their number sense to accurately and efficiently solve their problem. The previous problem involving the ladybugs is an example of this derived strategy known as adding or subtracting a group. Students are able to start with a nearby 2s, 5s, or 10s fact and then add or subtract a group. For example, I might not know 9 times 6, so I can think I do know that 10 times 6 is 60. Then I know I can subtract one group of 6 and get 54. Facts that include even factors, such as 4s, 6s, and 8s, can be found through the halving and then doubling strategy. This has been shown to be a powerful strategy. For example, I might not know 6 times 8, but I do know that I could half the 6 to make it 3 times 8, and I do know that 3 times 8 is 24. Once I have my 24, I can double it, and that would help me get 48. So I know now that 6 times 8 is actually equal to 48. With sufficient experiences with halving and doubling relationships, students learn to flexibly work to apply this understanding to unknown facts. Another example might be 6 times 7, where I can think half of 6 is 3, and I know that 3 times 7 is 21. So if I double 21, I can get 42. So 6 times 7 is 42. Multiplication squares can also be used to solve related facts and is an effective approach for some of the most challenging facts, such as 7 times 8 or 6 times 7. Students can apply their understanding of adding or subtracting a group to a nearby square, such as by solving 7 times 8. I can think, I know that 8 times 8 is 64, and if I subtract one group of 8, I get 56. Another example could be with the fact 7 times 6. I don't know 7 times 6, but I do know that 6 times 6 is 36, and if I add one more set of 6, I get 42. So 7 times 6 is 42. Finally, any fact can be found by decomposing one of the factors to create known facts and then recomposing the entire product. This strategy is grounded in number sense and will serve students well as they look for efficient ways to solve multi-digit multiplication problems. When children first begin decomposing, using a representation is key to keeping track of their process. They can represent using a model of equal groups, array models, and area models. Let's look at an example. I don't know 7 times 6, but I can decompose this array of 7 times 6 by decomposing the 7 into 2 and 5. And because I know the facts 2 times 6 and 5 times 6, I can then add 2 times 6 is 12 and 5 times 6 is 30. I can add together my 12 and 30 to get 42. Underlying all these strategies helps students understand the properties of multiplication, namely the commutative, associative, and distributive properties. Students apply these properties intuitively as they attempt to make facts easier to solve. Children will need frequent opportunities to explore, apply, and discuss multiplication strategies and properties throughout the year to move from fluency with strategies to mastery of all facts. This also presents another topic we will discuss in just a few minutes: the need for meaningful practice. Knowing multiplication facts does not automatically lead students to knowing division facts, just as knowing addition does not guarantee knowing subtraction facts. Division facts are the most challenging of the 4 operations for students. There are not many strategies currently used or identified at this time to support this acquisition. According to research, division facts are best learned using the think multiplication strategy. In the division fact, 54 divided by 9, we can think of this problem as 9 times what number is 54. There is no doubt that practicing multiplication and division facts are essential for mastering them or achieving phase 3 of becoming fluent. To maximize precious class time spent practicing facts, embedding that practice in worthwhile mathematical activities is important and the expectation in GCPS. Our office does not condone the drilling of students through flashcards or by assessing through time tests. Drilling isolated facts may, over time, lead to memorization of those facts, but that is the only gain. In contrast, meaningful practice involves helping students learn their facts through rich, engaging mathematical activities that provide the additional benefits of promoting problem solving, reasoning, and communication of mathematical thinking. Meaningful practice of multiplication and division facts begins with the use of related problems. It can be sustained throughout the year by reminding students to think of strategies they know when solving an unknown fact, and by expecting students to articulate those strategies verbally and in writing. Please be sure to check the ECOMM for great examples of meaningful practice for your students. Joe Bowler, a British education author and professor of mathematics education at Stanford, leaves the following quote for us to consider. Research evidence points in one direction. The best way to develop fluency with numbers is to develop number sense and to work with numbers in different ways, not to blindly memorize without number sense. To avoid pitfalls, we would like to offer a few tips to help you assist your students in becoming fluent with their math facts. First, it goes without saying that students will be more successful as they are efficient with foundational facts. Often, students are unable to make sense of derived-fact strategies presented in quick succession after their related foundational facts. There is another reason why it is important to throw away those timed tests and flashcards. Under the pressure of time, students just default to counting or detach from thinking rather than slowing down to consider a strategy that would eventually help them become faster and more efficient. Next, it is important to explicitly teach the strategies presented throughout this presentation, as well as using the resources found on the ECOMM to help students to acquire the strategies to help them acquire their math facts. Use of manipulatives and visuals are always encouraged in all math experiences to ensure student success. And finally, allow students to become familiar with strategies. Making sense of how the numbers are working together is how students become fluent. And remember, efficient to you and me might be different for our learners. It is important that students have strategies to draw from. We want students to have the ability to select and apply a strategy that is appropriate for solving the given problem efficiently for them. So this all sounds great, right? But now what? Great question. Let's go to the ECOMM and see what resources we have to help you with teaching our students how to become fluent with their mathematical facts. So when you go to your ECOMM page, you usually go to your grade level. Instead, I would like for you to venture over to the Math Office homepage. When you do that, once you've selected the Math Office button, you'll go ahead and scroll towards the bottom. This is a bunch of information that might be useful to you with our new Math Talks newsletter, all about our instruction and all of our instructional resources that are found at below. I'm going to have you go over to All About Math Fact Fluency. This button will take you to our Google site known as Math Fact Fluency, where it supports not only addition and subtraction, but also multiplication and division. On the front page, you will also find general information about what fluency involves. And then if you keep scrolling, you'll find the two different links that you can choose. You can either choose the tab at the top or these links that will take you to your desired location. In this video, we're going to go ahead and go to the multiplication and division. On this site, we have provided you with some resources to help you, our students' parents, and our students in helping them become fluent with their math facts. They provide games and assessment tools that I will show you shortly to support learning and retention of math facts. While the games the authors offer provide the opportunity to talk about strategies and practice a newly learned strategy, we encourage that these games do not take the place of problem-solving tasks in the classroom, where students are able to participate in those mathematical tasks that require collaboration and critical thinking. We do offer these games as a way to introduce the game in a teacher-led small group based on data that indicates that this student or these students need explicit instruction on strategies of the basic math facts. Bridge that partnership with your parents of the students in your classroom by having them play the games with their children at home, a fun way to lead students to math fact fluency. So let me show you where those are located. Once you go scroll down, you will find all of the foundational and derived fact strategies that I talked about in this video. To the right, you will find two different spots where it says activities for foundational facts and activities for derived strategies facts. When you click the arrow, you will find a whole bunch of listings of different math games that can be played with the students and helping them acquire those skills. So let's take a look. You are provided with the directions on how to play and what is needed. All of the games that are found on the site either need a deck of cards or dice, which most families have at home. And sometimes they need counters, but counters can be anything. They can be Cheerios that parents can find at home or pennies, just different things that they can use. But it's all easily found at home for parents not to have to go and purchase. But again, it tells you how many players, how to play it, and if they need to vary it, there's different ways for that too. And if there's any accompanying game board that needs to go along with it, those are also provided. So these are great little resources that they can use when they go home. There's also observational tools for you that you're able to use to help you keep track of who has what. There's lots of different versions, so I recommend that you go through and find which exactly one is best for you. There's also listings of our analyzing the standards and different thinking strategies for multiplication. These are GCPS math office resources, but we felt like we wanted to make sure that you had them right here so you don't have to go hunting. And again, for the derived strategies, different ways, different games that the kids can play in order to help them with their acquisition of their facts. So as we come to a close in this video, I would like to offer these two summary questions for you to consider. How will you support and develop fluency in your classroom? What ideas or activities are you most excited to try with your students? As I leave you today, please reach out if you have any questions or would like a thought partner about how I can support you and your students in their quest to master their mathematical facts. My email is listed below, as well as my office phone, so you can email or call me, and we are going to make sure that you are successful in helping your students acquire their basic multiplication and division facts. Thanks for watching, and have a great day.